Okay, so I just wanted to finish up with the database design that we were doing last time, but the implementation. Just to remind ourselves, remember that it's this, that we were trying to model this account structure, and we decided on a single table inheritance strategy, so there's going to be one account table to represent all of this data right here. And that's the easiest and the recommended way of resolving the difference between an object-oriented programming model where you have inheritance and a relational database model where you don't. And so we decided that this is what our account should look like, that our account table should look like. And then we were going to bring together the person table and the account table using this join table where we've got an ownership ID, parent ID, and account ID. We did that, right? Because, right? Okay. So let's. I'm sure that this came from last time. Basically, we created the person table. We created the email table. Remember that there's that foreign key that references back to the person table. We've got the account table here, and that's where we left it off. Remember that I was talking about the unique key here, and then I showed you the comic of why you would want to do this is because it maintains an ordering inside of the database so that it can look things up by an account number. If you're ever doing a select statement where you're using like or you're using equals and you're doing string matching or integer matching here, you want to make sure that there's a key on there, either a regular key or a primary key, so that you can exploit kind of like binary search, but it's not binary search, that's as a data structure. It's a tree data structure. We'll take a look at trees after the break, or sometime after the break. Anyway, the rest of it would be, of course, be, say, APR, which is a double, balance, which is a double, and both of these are going to be for savings accounts, account data, right? And so comma, comma there. Why am I allowing them to be null? Because for an annuity account, it's different, right? Annuity data. We've got a monthly payment, which is a double, and a number of years, so term years here, int, right? And so if this is a savings account, these two things will be relevant and they'll be set. But if it's an annuity account, these will not be relevant, and so I want to allow them to be null. If instead I allowed a default value of, say, 0 here, right, then how do I distinguish between a savings account of a broke person with nothing in it, right, versus a savings account that's not a savings account because it's an annuity account? Right? Don't do that. Allow them to be null. If it's missing data and it's allowed to be missing, it's truly missing, so let it be null. How did we decide to differentiate between these two things? Remember that we decided on this type here, and we called that a discriminator column. I don't know if I gave you the term or not, but this is called a discriminator column. Bad name. It doesn't actually discriminate. It's a better term for this would have been discernment, but I didn't name it, so I would have chosen a better name. Again, remember, in computer science, there are only two difficult things. One, caching validation. Two, naming things. This is a terrible name for it. But that's called a discriminator column. And our discriminator column here is going to be type, right? And I'll go ahead and keep this as a varchar 1, S, or A. If you had, if you had two types of accounts that started with A, annuity and awesome savings, awesome checking account or something, then you would need more letters here to discern between those two things, to discriminate between them. I'm not going to allow that to be null, though, not null. Because if it's null, that means it's missing, right? What kind of account is this? It doesn't make any sense. Remember, we are online, although nobody else is, so you won't be able to answer any questions live because you're not asking any questions live. All right, so let's go over here. It is highlighting type here. Don't worry about that. It's not actually a keyword. You can go ahead and use that as a column name here. If you find yourself doing this in your object model, you're probably doing something wrong. We do this here in the relational model because we have to, because it's not an object-oriented programming model. A type, like an actual savings account, the annuity account in Java, those are the types themselves. Right? If they had another type that said, I'm an annuity account, well, of course you are. That's what you are, right? And so don't, it's probably going to be a real, they're called code smells, right? It smells funky, it smells kind of weird. It doesn't necessarily stink. It's not necessarily wrong, but there's something off about it. Maybe it's probably wrong, right? So that would be a code smell to have any sort of type stored in any of your objects. The only time that that's different is that Piazza post that I put up from the other section, pointing out the only time that you need to discern between types is at instantiation when you create stuff. There you should be using instance of instead. Okay? All right, so savings count, annuity count, I think that's pretty good. Right? That takes care of our account. Oh, and now we need to take care of the join table here, the ownership table. Ownership ID, person ID, and account ID. And we'll just keep it simple for now, and that's all that we'll have. Right? So, ownership. I like to call my tables nouns, because that's what they are. Other suggestions would be owned by, right? But that's going from one table to another table. This account is owned by that person, right? If you went the other way, the proper terminology would be owns. This person owns that account. Again, don't get into grammar issues. If you name everything ownership, if you name everything a noun, right, then it works both ways. Right? Just like create table if not exists, that's not correct grammar either, right? But it gets the point across. Right? Ownership. The very first thing that I do on every single table that I've been doing up to this point is primary key, integer, not null, auto increment. So ownership ID. I'm also going to need to bring together those two other tables. So I need a person ID and I need an account ID. So person ID, which is an integer, not null. If it were allowed to be null, then that means that we're allowing orphans, and we don't want that. Right? We want to know who owns this account. It's not nobody. Right? Person ID and then account ID. Int, not null. At this point, those are not foreign keys. Do you remember how we did this? By saying that that column is a foreign key that references that table's column. All I need to do is cut and paste that. And cut and paste and modify for the other one. Account ID references the account table and the account ID within that table. Make sure you got enough commas there. There. That's it. Right? Let's think about this for a second over here, though, and let's spitball some potential problems. So let me highlight these two foreign keys right here. Okay? Person ID and account ID. Now think ahead here of being able to insert stuff. For example, what if I have person ID 123 and they own account ABC? Right? So person, account. Right? So this person, 123, whoever they are, they own account ABC. Right? We want them to allow them to have a different account, DEF. Right? Also, the same accounts or different accounts can be owned by the same person. So 1, 2, 3, 4, 5, 6. Different person, but same account here. There we go, DEF. Let's read these again because I think I read it backwards. Person 1, 2, 3 owns account ABC. They also own account DEF, right? So this one person owns two different accounts. This account right here, DEF, is owned by, this one account here, DEF, is owned by two people. That's perfectly fine. What if I did this though? 1, 2, 3, ABC. Should that be allowed to happen? Where I've got that combination right there and a duplicate or redundant record right here of the same values. Probably not, right? Redundancy is kind of bad. Like, you really own this account. I have two pieces of data that attest that you own this account. You only need one. Right? So what I'm going to do is I'm going to eliminate that possibility. Duplicates are not going to be allowed. To do that, I'm going to add what's called a constraint. So, constraint, I need to provide a name for this constraint. I'm going to just call it unique pairs, unique ownership pairs. You know, unique ownership pair. That's good. Right? Good enough. Move on. Unique ownership pair. And it's going to be a uniqueness constraint on the combination of person ID and account ID. There. That's going to say that the combination of these two accounts together is unique. Not that the person has to be unique. If the person were unique, they could only ever own one account. If the account were unique, then it could only ever be owned by one person. And we wouldn't have this, this many-to-many relationship here, right? Going back and forth. What I've done is I've said that the combination of these two things has to be unique. So you can't have 123 ABC and 123 ABC duplicated. Okay? There. That works. What else could I put in here now? I really like rules. Rules rules make things predictable as long as they're enforced. What kind of rule could we put up here in the account? Maybe for savings accounts. Focusing on maybe the balance and the APR. What would be an invalid balance? Actually, it probably wouldn't be invalid. A negative, right? Negative $10, you're overdrawn, right? And then you're going to be charged overdraft fees. So now you're not negative $10, now you're negative $35, right? So maybe that's not bad data. I don't know. But certainly APR here, no bank is ever going to pay you more than 100%. So let's go ahead and put in a check constraint here. Constraint. And I'll go ahead and say valid APR. I'll call it a valid APR. And I'm going to have a check constraint here that says that the APR must be at least 0. You can have negative APRs. Those are called loans. Right? And APR is less than or equal to, say, 1. Right? I just want to prevent the idea of somebody having 5% is actually 5. No, 5% is 0.05. Right? So this is what I'm trying to enforce here. Both of these are constraints. One of them is a constraint that causes uniqueness. Another one is a constraint that causes a check. Every time data comes in or every time a data gets updated, this is checked. And if it's violated, then it will not allow that insert. It will not allow that update. Now, that's the ideal world, right? And if we were in a proper database management system like, say, Postgres, then it would work. MySQL, it will not actually be enforced. Why? Because, well, Oracle doesn't want to add newer features to a free product because they want you paying millions of dollars for their database system. And as a consequence, we're not even using MySQL, we're using MariaDB. MariaDB does allow this and it does support it, but it shuts it off to ensure 100% compatibility with MySQL. Right? So this can be put in there, it just won't work. It just won't do anything. Right? In your assignment, go ahead and put in check constraints all you want. Design it however you want, great. But just know that it won't actually be enforced. All right. Account and ownership, I need to go ahead and make sure that I'm taking care of those up here as well. So actually, I'll ask you, where should it go? I'm going to go drop table if exists. Ownership. Should it go here, 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 or here? I could put it everywhere just to cover all my bases. Right. Oh, and ownership. Ownership. As long as I spell it correctly, I guess. All right, so which one? What about this one right here? Nope. I created it last. What do I need to do? Drop it first. Ownership, ownership, ownership. All right. So you need to go in reverse order of what you create stuff. Person, email, account, ownership, ownership, person, email, as long as the email is first, and then account last. Yeah.
How do you select the whole line? Right.
Like this?
Yeah.
Oh.
Is there a command for it?
Oh. So hold down the shift button.
Yeah.
And just move your arrow. Right. It's like doing it like this, like just, point, click, and select, but you're doing it with the keyboard instead. So shift and then down.
More helpful than like going to the end of the line, highlighting across.
Oh yeah. Or well, if you want to, you can always usually double click on a line, right? So There's more than one way to skin a cat, as my algebra teacher used to say. I don't know why he was skinning all the cats, but he was the kind of person to do so. So I'm sure he's dead by now. Right, there we go. All green, all good. Now, as a last step here, remember that this is what we're expecting from your drafts. We're expecting a draft and a sketch of what you're going to do. This is what we're expecting of your final design document. How do we go from here to here? We just did that. How do we go from here to here? There's a tool for that. MySQL Workbench. New model. Right? And by the way, I need to save this. Let's save this. I've saved it as foo.sql on my desktop. Come back over here to the model. Import. Reverse engineer a MySQL create script. Find that wherever you've saved it on your computer. Here is foo.sql. And hey, there is a nice little checkbox here to place imported objects on a diagram. Execute. Continue. Close. Done. Well, not done because it doesn't look pretty. Right. Put that there. Put that there. Put that there. And that there. Now it looks prettier. I don't know. There. That looks good. Or, you know, you can put it on the grid or something like that. Or you can have it way over here or whatever. Whatever aesthetics are most pleasing to you, go ahead and do that. All right. All right, any questions on this? And by the way, you can do it from this direction. You can go ahead and double click this, rename the table. You can go ahead and say, well, it's not an integer, or everything that you can do in SQL, you can do graphically down here. And then you can, instead of reverse engineering a script, you can take this as a diagram and then you can dump it to SQL, so you don't have to write any SQL. You can point, click, and do lots of graphical user interface stuff, and then dump it to an SQL file. I wouldn't recommend doing that though. I mean, once you get used to SQL, doing it graphically is kind of, nope. I don't, just like your question of how did I highlight something, right? A quick key. That's the difference between a regular old user and a power user. Knowing the quick things, right? So how do I select everything? Control A, right? How do I select just a line like that, multiple? How do I comment out entire blocks? Same block selection mode as every other IDE. Whatever you're selecting here, then command / because forward slash, I guess in this case. I don't know why it's forward slash. I don't know why I did that. Backslash? Nope. Weird. No, what am I thinking? That is a comment. / is a comment. Brain fart for a second. Right, there we go. There. Undo. Right. Or, yeah, here. Undo is what? Control Z, right? Cut is Control X, right? That copies it to the clipboard, so you can go to Control V to paste it, right? Yeah, once you learn the keyboard shortcuts for everything, then you'll be living in the Emacs world, by the way, or VI people are. So, do I have Emacs here? Nope. So I've got to go to C. There we go. So Emacs, foo.txt, right? That's just a basic text editor. Hello world, how are you? But everything here is at the command line, and so everything is here is keyboard based. Why? Because this predates mice, or the mouse, right? So, where is world? World. Oh, you didn't find it? There we go. There's the world. Where is you? Nope. You. There we go. What else could you do? You could cut entire lines here with one single keystroke, Control K. You're all taking 231 or 251 right now, right? Oh no? How many people are taking 251? The online Unix course. Do you go through Emacs? No, VI? What are you doing then?
Just basic terminal crap.
Oh, terminal crap. Like what? Awk?
Just like the stuff we did
Oh, like ls and
Yeah, just ls.
find a file starting here with the name foo.txt. There it is. Alright.
Or like group, I forgot, give me certain groups the ability to like write to a file.
Oh, chmod? Okay.
Yeah,
So you can have access to all of my files here if I chmod this to 777. I'm not gonna do that. You can do some pretty powerful stuff though. Hopefully you do get into sed, grep, awk, and all that other stuff. Have you talked about regular expressions? We're essentially done, so I'm just shooting the stuff.
I mean, Unix is kind of like, you open up the quiz the day before it's due.
Oh,
It
okay.
takes 36 minutes and you're done.
All right. Well, hopefully I can show you the real power of this stuff, right? I mean, for example, there's all my files. What's the oldest file that I have on here? Right? So what you could do is, what I just did was LSLA. I got all the information. These are the permissions. So that's read, write, and that's me. Read, write, and then execute. That's not an executable file. That's read. Everybody can read. Like everybody in my group, which is faculty, can read that, but they can't write it. They can't execute it. Everybody, including yourself, can read my whitelist. Who's in my whitelist? That's ancient. Okay. Some of those are my family. Some of those are from Netflix. I had to put in a whitelist because some of that's for spam, and that's so I ensure that I get their emails. But anyway, let's take a look at these files here. The dot means that they're hidden, so you don't actually see them. That's why the LSLA was necessary. The the LSL is long format. It gives me all that stuff. A is every file, even if it's hidden. Right? And then what you can do is you can start piping stuff. Have you done awk? No? Oh, wow. That's one of the most powerful things because you can use printf style formatting to do a lot of stuff. For example, I want to isolate the year here. That's 1, 2, 3, 4, 5, 6, 7, 8 columns over. There's just the years. Well, that's all of them in no particular order, so let's sort them. So what's the oldest one that I have? Okay, I'm getting some timestamps in there instead. 2001, right? Okay, well that's kind of weird. That's kind of long, so let me go ahead and throw that through a unique tool, right? Now I'm only getting unique ones, and then sort that. There we go. Right? Oops. No? Oh, there must be some like white space in there or something like that. Unique. Come on. Unique. And then that should sort it. Sort. Okay, anyway. I like sort all the time. Why? Because you can sort it randomly. Random. Random, there we go. That's how you can randomize stuff very easily. So if I take your CSV files, I'll just throw them through a sort random so that I jumble them up a little bit. Right? So you can do a lot of powerful stuff like this. Right? That's how I grabbed all of your test cases. So I just wrote a script, it was like 5 or 6 lines of just shell stuff like this to go through each submission, dump the jar files to a contents, move that over to a temporary folder, run our solution against it, and report back to me that it broke or for whatever reason. I deleted it out. Otherwise, if it passed, then it made it into the final one. So we still gave you the points, by the way, as long as the files were there. Right? No? What? Like, really weird. That, so you're just doing what are you doing? LS.
Yeah. PWD is like
Okay.
the most basic
Yeah.
of basic things.
Current working directory.
Yeah.
Oops. CWD. PWD full path. Oh, okay. PWD current working directory. Do we have Finger installed in this? Finger. There I am. Right. Finger is pointing a finger at somebody, and who are you? Oh, did they do Finger? because usually it's disabled. There I am in the Shore Center, yay. And it looks like there's my plan. Hi, there's my plan. Mail. Let's do somebody that I know. Chapin. He's out recovering right now. Hey, that's nice. He published a PGP certificate. That means I could encrypt email and send it to him, right? Using his PGP code. PGP is pretty good privacy, or GNU pretty good privacy, or whatever it's been renamed. There he is. I could, if you were not on medical leave right now, I could talk to him. Chat S. Chapin. Oh, he's not answering. Right. This stuff is ancient. This stuff predates my birth by at least 15, 20 years, right? Anything that you think that you're using, like right now, Discord, right? You're all on Discord, right? Where do you think that hash stuff came from? Where do you think the idea of Discord came from? Came from IRC. Like, I'll hang up on him. Come on. Oh, wow, it froze up. Okay. Oh, by the way, how do I log in without having to type my password every single time? I set up an SSL key, right? I can show you how to do that if you're interested. I'll post on Piazza. Otherwise, oh, what was I going to do? Oh, there. He ignored me. Oh, well. Because he's out, probably. IRC? Nope, we don't have an IRC client here. Internet relay chat? Old stuff. It's basically, Discord is nothing more than a pretty arguably pretty website put around IRC, right? And the IRC tags at, right? Those are chat box name bots, we called them back in the day, where you could register a nickname so that nobody else could take that nickname. All it was is somebody came along and said, you know what? These nerds over here are doing really cool stuff on computers. What if we made it pretty and shiny so that everybody could do it? That's how they make their money, right? IRC is old. Right? Anything that you can think of is probably really old. It's just that somebody came along and made it so that it was commercially viable. Okay, internet relay chat history. How old is it? It's got to go back to our 88. Yeah. So, old stuff. I mean, URLs are old. The first web pages. In fact, I can show you. Here's how we did the first web pages. What was it? Links? ESPN.com. There you go. There's ESPN. Yes. I'll allow your cookie. Yes. Always. There we go. Man, you got a lot of cookies. Okay. There we go. There, finally. There's what ESPN looks like in 1990. I don't know. These are just links here, alternate links, buttons. There we go. Let's find out what the Blackhawks score was the other night. Scroll. Right, space. There's scores. Right. I'm not gonna bother here. They lost, I know. Oh, there though. So Friday, today, we've got there's the Blackhawks. They're going to be playing the Panthers tonight, and the over/under is 6. And of course, the Panthers are heavily favored. Tickets low, $15. So, don't think anything that you see out there is new at all. It's been done before a million times. Right? It's just that it wasn't as pretty. All right, there's your history lesson for the day. Any questions? Otherwise, that's where I was going to end it anyway. With where's my workbench over here? There's your ER diagram. You can save it. You can export that as a PNG, export as a PNG or an SVG, right? Or a PDF, right? Apparently. We never put in any. I guess one thing that we could do, but I trust you to know how to do it. We never put any test data in here, right? So you could insert into person, values, or sorry, person ID, first name, last name, and then I'll omit date of birth here, values, me 10, Chris, work. There we go. Somebody else, fake, I don't know, Anita, Borg, 30, here, as long as we're doing internet history lessons here, who's Margaret Hamilton? Margaret Hamilton. Who? She's the one that,
Hamilton or Alexander?
no, not Alexander Hamilton. She's still alive. Margaret Hamilton is, I believe. She came up with the term software engineering. She did like the Apollo moon mission, software for the Apollo moon mission, etc. Anita Borg is also a famous computer scientist. And then maybe, I don't know, Alan Turing. He's definitely dead. Alan Turing. Right. There. Just put in test data. Put in test data here, put in test data here, put in test data here. That's what we're expecting for your next phase, not this week. But remember, the reason that I'm hard coding these values is so that when I insert an email, I know that I'm going to be inserting that email for me, or for Margaret Hamilton, or for Alan Turing. For test data, it's perfectly fine to hard code those values. But you'll still want to make sure that you're using auto increment after that. There's nothing extra that I can do. At least I did that I prepared for. What we would do next time is wrap this up as a review of stuff that we've done here. For example, you know, I'll make sure that you, oh, here, I need to make sure that you've got this in the notes so that you can reference it if you want to. So there we go. There, now it's in the notes. So observations. What naming convention did we use? Just be consistent, right? Our suggestion is to use upper camel casing singular form for table names and lower camel casing for columns. More after the break. That's fine. Didn't mean to make you come for just a half-hour version of it. No questions? Questions about homework then?
Maybe show us how to do the second report.
What's the second report?
That's just the store one. That's not the hard one.
Oh, okay.
On anyone we haven't done yet, it's the second.
Okay. Well, what does your store look like? It's got a code, right?
Yeah.
All right. This is the bad text editor to be doing this in, but whatever. Oops. Open a new window. Come on. Come on, new. Okay, fine. I'll do it over here. So what is your store?
Farmer.
Well, yeah. What is your store class? I just.
Yeah, we've got the.
Well, what's in your store? Like, there's a code, right?
Yeah, there's a code, and then there's the manager code, and then there's the address.
All right, is a manager a code?
It is ours.
Okay, then maybe it shouldn't be.
Well, it's a code that maps to a manager.
Oh. So then how do you get the manager?
Like,
How do I print out their last name?
by adding a new manager or a new person.
So where is that map stored? Inside the map, the store class?
No, it's stored in, it's when we parse through the data.
Sure, but then why does your store not own a manager instance?
So we just got a string from the manager code.
Yeah, that sounds like bad encapsulation, bad modeling, person.
Is that in common with that RMS?
Yeah, there you go, that's what they meant.
Oh, yeah, that's.
So,
Well, it didn't say
Another
anything
thing is
about.
Oh.
I don't think our TA actually legitimately looks at it.
okay,
We're kinda unfortunate, we get like 2 or 3 comments over the whole thing.
Right, is
And
that-
like, he's like, add more, and that's it, but it's very unspecific, and then he takes out points and you don't exactly know what he's talking about.
alright, well, email me about that and I'll,
'Cause I don't think
I'll
he
take a second look.
knows what each one is.
Okay.
So we've got, you know.
There are baffles up here, nobody can hear you.
So should have, the store should have a person rather than.
Why not?
just-
That's what a manager is, right?
Yeah.
So what else does a store have? You didn't have like street, city,
No,
zip,
we have-
right?
We have an address.
Right. Exactly, so it needs to be a person too, right? An address is not 5 strings, an address is an address. Right? Okay, what else does your store have? I think there should be more, what? Nothing? Is a manager, store, okay. So then, the second report that you're having a problem with, you wanna know how many sales did this store make? What's the total number of, total of value of all the sales that this store made? I don't see any information here that can tell me that. So let's solve that.
Like a function that,
Uh, we're just talking about state right now, right? Variables. We can do functions later. What,
invoice count.
all right, invoice count, which would be, say, an integer. Invoice total, which would be a double, all right? That would be if you did it as state. What would you need to be able to calculate those things, though?
All the invoices.
All right, all of the invoices. Translate that to Java. Where would you store all of these invoices? You could do it in a map, mapping what to an invoice.
Invoice code to invoice.
Okay, you could do that, if you've got like a string that represents the code. But let's simplify it. Once it's in a store, do we really care about, I mean, you care about that when you're parsing, right? But do you care about it at this point when it's in a store?
Not really,
All right, so, because you've already put it into the store.
just one invoice.
One invoice?
List invoice.
There you go. List, or a set, or a collection. Right. Now, do you need these? How would you do an invoice count? I'll call it foo. Don't call it foo. How would you do the first one? There you go. Done. How would you do the second one? Well, loop, right? For each invoice in foo, right? Total plus equals invoice dot total, or whatever you're gonna call it, right? So, that's your behavior, right? You're confusing behavior and state, right? That should not be a variable that's stored. That should be a function that somebody can call, and you tell them how many invoices you have, how many, what's the total of all of the value of each invoice or whatever.
Okay, that's what we did then.
That is, okay.
I really didn't have a question, to be honest.
Yeah, we don't have.
I
we
just
don't have a
wanted
list
like
of invoices, though. We just have to use the whole map, and then we have a dot equals function for the invoice code.
Oh, hopefully you overrode the equals and hash code method then, because that ain't gonna work otherwise.
Maybe equals and hash code method.
So, when we did persons, well, here, I've got it somewhere in here, code, person, right. Equals and hash code. It's based on the first name and the last name. That's when I generated that, right? That's because that's how we identified a person, first name, last name. If you had something different, like private social security number, then you would want the identity to be based on that, and you would want to generate equals and hash code to be based on that. Just that. It will probably work even without that overriding, but you have to be careful on duplicates, because if you create John Smith, John Smith, John Smith, John Smith, and they're all the same persons, but different instances, your map will not realize that they're the same person. You'll have 4 John Smiths in there.
We have the mapping to their person code.
Oh, okay, then there you go. You should, that'll work, probably, and probably. So, that reminds me of another time in my industry experience where I wrote this algorithm based on maps and based on tree maps for load consolidation, and the priority went something like the closest one, then the cheapest one, then another piece of criteria, and I knew that, okay, well, we're gonna have to make sure that there's some tiebreaker at here, because if they're an equal distance away, if they cost exactly the same, I don't want to lose them. And if there was not a tiebreaker, then as far as my comparator was concerned, they'd be the same load. And they're not the same load. That's load A, that's load B. And so my tiebreaker at the bottom was the database ID, right? And then somebody comes, and I code reviewed everything, I checked it in, we put it into pre-production, and then a colleague, without telling me, without asking me, without doing anything, says, code, that's irrelevant, right? We're just doing distance and cost. So I'm gonna go ahead and take out that last line. Then didn't tell me a damn thing, right? And it goes to production, and now, I think it was Kraft, they're calling over and saying, we're missing a lot of loads here. And so I have to go in. Thankfully, we were using something like Git, and it was SVN at the time. And I could see somebody changed my stuff. Who changed my stuff? Why did you change my stuff? Let me explain to you computer science 1 stuff over here about identity, or computer science 2 stuff about identity. You need a tiebreaker here, otherwise your map is not going to distinguish between those 2 loads. Put it back in. Right? So I don't have a lot of stories like that, but I remember those kind of stories like tend to stick out in your mind because it pisses you off. It costs a lot of time, right, and effort. But so equals and hash code method, you probably want to think about doing it. It's probably not going to be necessary in this case, but yeah, if you've got a list of invoices, you should be able to sort the store appropriately, right? All right, so that wasn't really your question, or?
It was just time filler.
That's just what we have.
I mean, you don't have to fill the time. We could go.
It was also to see if like.
It's also nice to have some.
Yeah. Like
Okay.
Some actual like common, what we.
Sure, understood.
We're actually doing.
Unfortunately, I grade everything up in Omaha, and then I grade in the main section to relieve some folks, and then unfortunately, I don't get to the H section. Maybe I'll rotate into the H section for next time or something. I don't know. All right. Any questions? Or I think in the future I might actually consolidate the grader pool so that there's a larger pool of randomization. No questions at all? You don't want to see anything? No? All right. Well, I already showed you the comic. SQL. I showed you that comic, right? Yeah, that guy right there. Eventually we're going to get into SQL injections, and Little Bobby Tables is always posted everywhere. Have you ever seen that one? XKCD. So that's another great, nerd programming, whatever, comic. This is about SQL injections, where if you don't sanitize your queries, somebody can append SQL statements to the end of your like in a web form, you put in your login. Instead of putting in your login, what you can do is you can put in Robert, and then a double quote here, and then drop table students. What's drop table students doing? It's deleting that table, right? So what ends up happening is if you don't sanitize your inputs, then you allow somebody to put in arbitrary SQL code in a web form and have it be executed on your server, right? And so they can drop your table, right? So this is your son's school. We're having some computer problems. Did he break something in a way? Did you really name your son an SQL injection? Oh yes, Bobby Tables, we call him. Well, we've lost all this year's students' records, and I hope you learn to sanitize your database inputs, right? So stuff like that. Go to XKCD. I don't even know if is it published anymore. Like, does he do new stuff? All right. Come on. And it's nice too because if you don't have the background, I think that there's XKCD explained or something. I don't know. If you look at her daughter is named Help. I'm trapped in a driver's license factory. Anyway, there's stuff all there was a Radiolab podcast a couple months ago maybe about a guy, programmer who legally changed his last name to Null because he wanted to screw up, or maybe it was either that or he got a license plate that said Null, thinking that I imagine that they didn't do too well in their design of their the traffic cams that will automatically read your license plate. So he thought, I wonder if I can get away with stuff if it's Null, right? And just the opposite. Everybody whose license plate could not be read was interpreted as Null and then sent to him. So instead of getting 0 tickets, he got thousands of tickets that were not his. So I guess screw around and find out. But there you go. Only 5 minutes left. Have a good break.